Dr. Anna Silva. She is the assistant or associate professor, if I'm not mistaken, assistant professor at the Polytechnic Institute, which is a well-built academy in Lisbon, in Portugal. And she's been, specializing in sport neuromedicine and how to utilize neuroscience and neuroplasticity to empower the athletic performance in professional athletes. And I know that Anna, she has a great insight on this, and she's going to introduce some ideas regarding the way that, like, how neurotech research is to inform neuroscience and sport medicine together. The floor is yours, Anna, and glad to have you here. Go ahead, my friend.
Thank you. So I will share my screen, my presentation. Okay. Now, first of all, thank you for your invitation and for the organization. First of all, and especially Professor Mohamed Nami for inviting me to be here today. It's with a great pleasure that I'm here today. And in advance, I would like to apologize if my presentation will be too much academic. But at the end, we will have some discussion, and feel free to contact me to some other questions and other topics in the sports medicine field.
That's great, Anna. We like academic stuff, so feel free. Yeah, go ahead.
So my name is Ana Filipa Silva. I'm a professor and researcher from a sports faculty in the north of Portugal. And I'm also a co-founder of High Performance Brain, which works in Portugal and Netherlands. So today I will share with you some insights about the sports research regarding the brain, the brain analysis, the brain stimulation. So it is well known that brain stimulation and brain analysis in the treatments and the medical treatments, but in the sports field, this topic it's recent. So some 2 decades ago, some researchers bring these ideas to the field of sports, trying to push the limits of the athletes. So trying to go to the full limits of those athletes, because we know that improve milliseconds in sports, it's a great result. So we would like to achieve more and more results and understand all those behaviors and all those characteristics of experts. So until now, we know the behavior of the experts. We understand and compare the experts and non-experts, the elite and non-elite, so the older and younger athletes, trying to understand their behavior, their characteristics, to copy that and have another Cristiano Ronaldo in the few years. So, but regarding these neural mechanisms, we do not know a lot. And that's why we are speaking about this sports medical research. Two main brain stimulation techniques are used or could be used in sports field, and in this. I will go to the sports field and try to focus more on that. So the transcranial magnetic stimulation, and also the electrical stimulation, which the transcranial direct current stimulation, it's the most used. In fact, in one hand, we have the transcranial magnetic stimulation that involves the discharge of a brief magnetic pulses, and also it could induce inhibitory or excitatory effects on the target brain area. The immediate effects of this is the great or degeneration of the potential of these cells, followed by a refractory period in the cell's recovery. On the other hand, we have the transcranial direct current stimulation that involves passing a weak electric current that normally in the sports papers are between 0.5 to 2 milliamperes from a negative to a positive electrode. So this involves modulation of the resting membrane potential of the cells, which means that it's not sufficient to activate the brain region. In fact, this technology, it's more like a neuromodulation more than, or rather than a neurostimulation. However, when comparing these two techniques, we can see that TDCS technology is cheaper and more portable than transcranial magnetic stimulation, which means that it is a great news for sports clubs and for our study in movements. However, the transcranial magnetic stimulation is more focal technique and focus on a small area of the brain. And the TDCS could spread across the whole brain surface. But the main reason why all or almost all the studies are with the TDCS is that it is a cheaper technology, and we could use safely in athletes. So I will show you some papers, some results of the papers, just to understand what the literature said to us in nowadays regarding this topic. So maybe this study was the first to bring this methodology to the sports field, and they were the aim of this study was to understand if the TDCS could modulate the neuromuscular fatigue on the endurance time and in a submaximal isometric force contraction. So we have to understand that when we are speaking about sports or muscle contraction, we have to define what is that muscle contraction. So if it is a longer, a dynamic, isometric, which is the main movement characterization. So in this regard, in this study, the analysis was in isometric force. And the results showed that endurance time after a nodal transcranial direct current stimulation was significantly lower, more or less 15% when comparing to cathodal TDCS and the control group. So this was the shooting point, the shooting start for analyze those techniques in motor cortical areas. Another study, in this study, these authors analyzed cycling, so cyclic athletes, and they tried to know if this technology could really develop the peak power output, which means that it is the intensity that in this case the cyclist could maintain for more than 1 minute, the maximum power, and they try to understand if the perceived exhaustion, which means that the perception of the effort and the heart rate will be different using this technology or not. And the results also showed great insights in this field, following or showing that the nodal TDCS improved 4%, around 4% in this regard. And also the perception and the heart rate were significantly reduced. So great news for sports fields. With these results, these authors suggested that this technology could have reduced the perception by affecting the activity of the insular cortex and this will lead to an increase in exercise tolerance. Another study in
Dr. Anna, can you elaborate on RPE, what it stands for?
It's peak power output. So it's when in this case an athlete, a cyclist, could achieve their maximal power output and maintain with more than 1 minute. So it's a measure that analyzes the strength, the capacity to produce strength and power in the maximum and maintain. So this is a great measure to analyze the capacity, the strength capacity of these athletes. Okay, so in this study, also in cyclists, the aim of that study was to determine the effects of TDCS once again on physical performance and also in physiological and perceptual variables. So in line with the last study. And I bring this study to you because also it was observed improvements in the peak power output, so the strength of those athletes. So it is great. We have an empowerment on these athletes. However, no significant effects were found in the perception of the effort and the heart rate. And this is different results of the last study. And keep this in mind, because at the end I will highlight again those characteristics or those results. Another study with a well-known co-author, so Professor Mohamed Nami. We have this study here that focused on bodybuilders, and they were trying to understand the effect, once again, of TDCS in the athletic performance of these athletes. So once again, this methodology, this technology, could decrease the perception of the effort. So it is RPA. It's a measure of internal load, so of internal perception of the effort, which is very important to maintain the effort during the play, during the sports, the playing sports. So it is great to improve this or in fact decrease this RPA, because the athletes are asked to say, how do you feel right now from 0 to 10? Like 0, it's almost fresh, and 10 is almost dying. So we would like to decrease this value to have a lower perception of effort. It does not mean that they are not playing well or playing with all their effort, but their perception is lower. So it's good. These values of the effort perception and heart rate also decrease in this study. So it is a great result. Also, in the capacities, the strength capacities, is like the maximal repetition and the endurance, the muscular endurance, were also beneficiated by this technology. However, in this study, no difference in motivation was observed. But at the beginning of the study, they showed great results on motivation. So that's why maybe that's why the difference was not so clear. Okay, here there are another study in pistol shooters. So those authors try to analyze the performance of these pistol shooters using this technology, the TDCS, once again. And improvements of around 2.3% were observed in their score. And also important, less errors. which is a great result with in this group that use TDCS. And in addition, better results in the mirror tracing test in this group. So once again, more great results that highlight the benefits of using this technology. However, the science is not made by just one paper. So this tool, the systematic reviews and meta-analysis, help us to understand what the literature say to us nowadays. And in this study that focused on isometric strength, those results showed that the maximal voluntary contraction and muscular endurance through isometric contraction. Isometric contraction is a contraction with no movement, so it's just sustain a load. It is not dynamic. And we observed that this meta-analysis that included 14 studies showed that really the TDCS really improve the maximal movement contraction and the endurance in this specific movement, the isometric contraction. However, regarding the overall endurance, so maintaining this overall action was not significant on those results, on those movements. At last, the last study that I will present to you, it's also a review, and I bring to you because this includes not only real effects on performance, so in strength, in fatigue, and so in contraction, but also in motor learning and processing speed. So this review highlights the importance of these technologies to improve not only the performance that we can see and we can analyze, but also the process to achieve that performance, which is a good news for youth and to improve those the performance of youth athletes. Okay, just an overall discussion of those studies. Despite we have a considerable body of studies that highlight the importance of brain stimulation and these technologies in sports medicine, being considered also as a neurodoping, there is no consensus in some effects and some magnitude of effects of those technologies. As I already highlighted in the last studies, there are some studies that are in line with the same results and some others that don't. So to further researchers to motivate to another and to implement another researchers, my suggestion is to establish some protocols, which means that in different papers we have slightly differences in the protocols, and there is a need to compare different protocols with time, with the intensity, and maybe doing more than once, so not acute effect but a longer effect on athletes, on really athletes, to understand the real effect of this methodology. Further, or in addition, I would suggest to do further studies in this regard. In fact, some of the studies that performed or used this technology used a sample of active people, so people that practice physical exercise and not just athletes. And we need to focus more on athletes because we know that regarding the power law, the possibilities to improve our performance when we are good, it's less than when we are not so good. So we have to really understand the benefits and establish those benefits and spread the word of those benefits to athletes and to include on sports clubs. Also, we have to understand, or we have to have in mind that this sports field and brain and sports field is recent. So as in all other sciences, we start with the characterization, we start with the basics, and then we go deeper and deeper to understand the other questions that emerge when we are more deep in the study. So we are at the beginning. We have to implement more interventions and understand the benefits, not only for the physical characteristics, but also for the psychological, the cognition benefits. And also, just to add that more studies, or the great part, the majority, or if not all the studies, are focused in one movement, in movements that are more related to individual sports. And we know that or jumping to sports, to team sports, we know that the focus, the attention, the decision-making are really important to understand the real performance of the player. So individual sports are normally closed abilities, so predictable. And we would like to jump to unpredictable, so to improve the capacities of the sports athletes to creativity, to decision making, to improve their capacities to fast understand the context and make a decision. So this is my main motivation to go deeper in these fields, and I share with you my thoughts. So thank you for inviting me to be here. It's a great pleasure. Thank you, Professor Mohammed.
Sure.
These are my email, my social media. Feel free to ask or to propose some work. So I'm available for all of this.
Thank you, Dr. Anna. Great talk. You know, actually, the NeuroGrant is thankful to you for your contribution, and it was much of insights and thoughtful comments and ideas, and it might not be only limited to the people who are working on, like they are novice in terms of their sport activity. They might be very professional, or they might be even at very high end level, like they're Olympians and they want to get medals, but the gold medal should be a gold medal, not a silver one. So how neuroscience can turn a silver medal into a gold one, and how we can potentiate or empower the athletic performance. And as you beautifully summarized, there are emerging tools in neuroscience which can potentially inform us how we can help neuroscience to enhance the athletic performance. And there's a much discussions on this, of course, and where time is limited for this round, but we certainly can, touch on different perspectives around it as we have further rounds of NeuroGrant activities. So if you or anyone else there in Western Europe are interested in Netherlands or in Portugal that will work together there, or we now have the family of Zarela, just to spread the word. If you have people, your students, your scholars, any of the professors, you're more than welcome to be part of the initiative. Let's design studies. We already have designed one for Taekwondoans, and we're submitting the methodology of that research methodology. It's already in hand, and I'll let you know. So whoever wants to be part of this, this is a very open atmosphere. Just let them know that the concept of Zarela and the platform of what we do at Zarela is available for their contribution. Great talk. Appreciate that again.